Hello everyone. Now we are going to start a very interesting part of your syllabus, which is calculus. And we'll begin with the chapter continuity and differentiability. In this video, we will deal with the topic continuity. Now, as the name suggests, continuity means continuation of a graph that is not broken at any point in the real number domain. Alright, so now see, suppose you have a function fx defined as 1 for all x smaller than equal to 0 and 2 for x greater than 0. Now look at this function. Okay, so the value of function for all x smaller than 0. So for all the x real number line, all the x's smaller than 0, your value is 1, right? Something like this, for all the x's you will get the value 1, and for 0 also it's 1, so this point is included. Alright, now for x greater than 0 means on this part of the number line it's 2, right? It goes like this, and 0 is not included at 2. Now you see, is this function continuous? Now in layman's language, a function is continuous if you are able to plot that without lifting your pen. Means there is no breakage in one line, in a single line. If you can map that function, if you can draw that function, then that function is continuous. But here you see, you go up to here and then you have to lift the pen and then draw this. So there is a breakage on this point 0. So at point 0 your function is not continuous. Overall the function is not continuous. Now in the same function, if it's like 1 when x is not equal to 0 and 2 when x is equal to 0. Now look at this function. How is this going to be drawn? Here. Alright, so at x not equal to 0, everywhere the function has the value 1. Alright, so at this point, if you leave 0 point, everywhere this is the graph of the function. Alright, at 2, this is the point. Now you see, again this function is not continuous because from here it's going continuity, the continuity is maintained. But when you reach at the moment where you reach 0, the graph breaks and the point is 2. Right, so this way also your function is not continuous, means in one stroke you cannot map this graph. Alright, this point is the point of discontinuity here. Which point? 0 point. Alright, now in earlier classes you have read the definition of continuity that says if limit x tends to c, suppose at any point, at any point c you have to check the continuity. You will say if the left hand limit of the function is equal to the right hand limit of the function, x tends to c plus, means at the right hand side of the c, and if it is also equal to the function value of the function at this point c, then your function is continuous, right? You remember this, then fx is continuous. Yet another definition of continuity says that if f is a real function, fx is a real function, and c is a point on the domain, c is a point on the domain, the domain on which your function is defined. Now the function fx is continuous at c if limit x tends to c, fx is equal to f of c, means the value of this function at c is equal to x, the value of the function when x tends to c, means at some point c, suppose this is a point c, and if we are tending towards this point, means slowly we are tending, we are not exactly at c right now. For this part we are not at c, we are tending towards c. Some way, little by little we are tending towards c, and if you get the value same as the value on this point, then your function is continuous. Suppose fx is equal to 2x plus 3 and we have to check the continuity at x is equal to 1. Now you see what we have to do. Limit x tends to 1 of fx. We will find the value of this. That means x is tending towards 1. So we will put this. Now this x is actually not equal to 1, but it is very closely turning to 1. Here you get the value 5, right? And f of 1 is also 5. So your function is continuous. Now let us check the continuity of f of x is equal to mod x at the point 0. Okay, at x is equal to 0. Now you know how mod function is defined. Mod function is defined by what? Minus of x when x is smaller than 0 and x when x is greater than or equal to 0. Right? This is how your mod function is defined. Now let us check. We have to check at x is equal to 0. Right? At 0. Now what we are going to do? We are going to check the left hand limit and the right hand limit. And you know, for mod of x to be continuous at 0, left hand limit should be equal to the right hand limit, should be equal to f of 0, right? So you know, limit x tends to 0 minus. This means we are moving from the left side. We are moving from the left hand side and tending towards 0. Okay, f of x is equal to what? So for you know this very well. When we are tending from the right hand side, we will change this limit to h tends to 0. Okay, when any point is given and we have to turn it to 0, we'll do for x tends to 0 minus h tends to 0. We'll change this function. So it becomes a function of f of 0 minus h. I hope you remember this thing. Now you'll solve this. This gives you limit h tends to 0 of what? For negative, for less than 0, 0 minus means less than 0. Your value is minus of x. So it gives you what? Minus of 0 minus h, right? So it's what? Minus 0 plus h. So it's h, alright? And similarly, your right hand limit. This is your left hand limit, okay? Now your right hand limit, we are going to find your right hand limit. You see, limit x tends to 0 plus f of x is what? Limit h tends to 0 and what is the value? X, right? At x greater than 0 at the right hand side, when you are approaching from the right hand side, the value of the function is x only. Okay, so that means in the place of x we will put 0 plus h. First of all we will put 0 plus h. Okay, and if you are thinking why I did this way, let me repeat one, increase a step here. Let me increase a step here for you to become clear. So this can be now written as limit x tends to 0 negative. F of x is what? Minus of x. Alright, this is how you got minus of 0 minus h. And here this can be written as limit x tends to 0 minus 0 plus, what is the value? Plus x, means this, right? Now it becomes when we are approaching from right hand side, it becomes 0 plus h. Alright, so again you got the value h only, right? At 0 plus h, it's h. Alright, now we got the value at left hand side and the value at the right hand side. Now we will find the value of the function at the point where we have to check the continuity. Now we will find the value of f of x at x is equal to 0. Right, so f of 0 is going to be what? 0 only. So you got h is actually what? H is a very tiny value, infinitesimally small value that is equivalent to 0. So somehow this is going to be 0 only. Okay, and at 0 also you got the value 0. So you got left hand limit is equal to right hand limit is equal to f of 0. That means your function is continuous at 0. Now pay attention to this question. Here fx is defined in two ways. X plus 2 when x is smaller than or equal to 1, and x minus 2 when x is greater than 1. And now we have to check the continuity of this function. The question is asked like this: discuss the continuity. Alright, now you see, this function is defined on all the points of the number line. See, for all if this is a number line, real number line, for all the c belonging to real number line, for any point c on this real number line, this function is defined. You see, everywhere this function can be mapped. If you take c as any c, you will get certain value, right? Okay, so now we have to check whether this function is continuous throughout this real number domain. Alright, so we will take any c belonging to real number. Let c belongs to real number. We will say we have taken any real number. Now you see in this way. Okay, so this is our real number line, suppose, and this is some point c. Okay, so if your c is less than 1, if your c is less than 1, if c is less than 1, let us check whether this function is continuous or not. You know how you are going to check. Limit x tends to c, f of x is equal to f of c, right? So what is x tends to c fx? When c is less than 1, your function is defined like x plus 2. That means limit x tends to c, x plus 2, right? That means c plus 2. Okay, and the second part, f of c is what? C plus 2 only. So you got both of them are equal. So for all c less than 1, your function is continuous. If this is 1, okay, and for if you take any c at this part, if you take any c, the function is continuous. Oh, alright, and similarly you will check and you will find also that the function is continuous for all the c greater than 1. If we take c greater than 1, then your function is defined as x minus 2. So if your c is at this part from 1 to infinity, anywhere on this part of the number line, if we take c, we will see that there also the function is continuous. How? Do the same thing. Limit x tends to c. Alright, we are taking from considering c from this part and dealing with this function, because x greater than 1, for x greater than 1, your function is x minus 2. Alright, so it's x minus 2, that means c minus 2, right? And for f of c, you have c minus 2. So for x less than 1, for any c less than 1 and any c greater than 1, your function is continuous on both the side, on both the conditions. Now what is left? At x is equal to 1. Now we will check the continuity of this function at x is equal to 1. Alright, इसको बहुत ध्यान से देखो. आपको दो पार्ट मिले. आपको क्या करना था कि इस फंक्शन की कंटिन्यूटी चेक करनी थी. आपने देखा कि फंक्शन पूरे रियल नंबर डोमेन पे वैलिड है, तो आपको पूरे रियल नंबर लाइन पे इसकी कंटिन्यूटी को चेक करना था, राइट? तो आपने देखा कि फंक्शन कहाँ पे फ्लक्चुएट कर रहा है. पॉइंट 1 पॉइंट पे फंक्शन फ्लक्चुएट कर रहा है, अपने ग्राफ से चेंज हो रहा है, ठीक है. तो जब तक फंक्शन 1 से लेस था, जब भी x आपका मतलब फंक्शन नहीं, आप x लेस देन 1 ले रहे थे, फंक्शन कंटिन्यूस जा रहा था, ठीक है, आराम से. सपोज ऐसे कोई कंटिन्यूटी में जा रहा था, आपने ये चीज़ देखी. अब आपने जब x को ग्रेटर देन 1 लिया, आपने इस डोमेन की बात की, तो यहाँ पे भी आपने क्या पाया कि फंक्शन आपका कंटिन्यूस है. सपोज ऐसे ही जा रहा है, ठीक है. अब एट 1 यू डोंट नो वेदर द फंक्शन इज कंटिन्यूस और नॉट. तो अब आपका मेन जो मोटिव है वो 1 पे प्रूव करना है कि फंक्शन कंटिन्यूस है कि नहीं है. मतलब आप एक स्ट्रोक में पूरा ग्राफ बना पा रहे हो कि नहीं बना पा रहे हो, बस अब 1 पे चेक करना है. अब किसी पॉइंट पे कंटिन्यूटी चेक करनी होती है तो वो बहुत सिंपल चीज़ होती है. लेफ्ट हैंड लिमिट और राइट हैंड लिमिट निकालो और उसको इक्वेट करके देखो. अगर दोनों इक्वल है और 1 पे जो वैल्यू है वो तीनों अगर आपस में इक्वल है, तो फंक्शन 1 पे कंटिन्यूस होगा. तो वही चीज़ हम करेंगे. ठीक है। फॉर एक्स सी पे बात कर रहे थे ना हम, सी हमने लिया था रियल नंबर का पॉइंट, तो सी इज इक्वल टू 1। देखो सी स्मॉलर देन 1 पे आपने चेक किया था कि कॉन्टिन्यूस है, सी ग्रेटर देन 1 पे भी आपने चेक किया था कॉन्टिन्यूस है। कैसे चेक किया? किसी डोमेन के अंदर अगर फंक्शन चेक करना होता है कंटिन्यूस है कि नहीं है, क्या करते हो आप? लिमिट एक्स टेंस टू सी एफ एक्स इज इक्वल टू एफ ऑफ सी, यही तो करते हो। तो वही चीज़ मैंने दोनों पार्ट में की। जब सी 1 से छोटा था तब भी मैंने ये अपनी यही जो डेफिनेशन थी, लेट मी राइट इट इन अ नाइसर वे, लिमिट एक्स टेंस टू सी एफ ऑफ एक्स इज इक्वल टू एफ ऑफ सी, ये आपकी फंडामेंटल डेफिनेशन है। अब ये डेफिनेशन मैंने सी लेस देन 1 पे भी लगाई और सी ग्रेटर देन 1 पे भी लगाई। दोनों केसेस में मुझे ये कंडीशन जो है मतलब वैलिड मिली। तो मैंने पाया कि इन दोनों पॉइंट्स पे तो मेरा फंक्शन कंटिन्यूस है, मतलब इन दोनों डोमेन्स पे, पॉइंट नहीं है, पॉइंट तो 1 है हमारा, इस डोमेन पे और इस डोमेन पे मेरा फंक्शन कंटिन्यूस है। नाउ वी विल चेक फॉर c इज इक्वल टू 1। अब इस पॉइंट पे चेक करना है, अगर यहाँ पे ब्रेकेज नहीं है तो थ्रू आउट द रियल नंबर लाइन आपका फंक्शन कंटिन्यूस होगा, अदरवाइज द फंक्शन विल बी डिसकंटिन्यूस एट 1। ऑलराइट, नाउ लेट अस चेक। We will find the left hand limit. You know how is it find? Limit x tends to 1 minus अपर साइड पे लगा देना है आपको, f of x इसकी वैल्यू निकालते हैं क्या है, what will this give you? अब 1 माइनस लेना है, मतलब आपको लेफ्ट हैंड साइड से 1 पे अप्रोच करना है। तो आपकी वैल्यू क्या होगी फंक्शन की? x लेस देन 1, x प्लस 2, मतलब लिमिट x टेंस टू 1 माइनस x प्लस 2 लगाना है। ठीक है, अब इस 1 माइनस को आपको पहले h टेंस टू 0 फॉर्मेट में ले आओ आप, लिमिट h टेंस टू 0, एंड यू नो व्हाट h इज, h इज अ वेरी स्मॉल वैल्यू, infinitesimally small value which is actually tending towards 0। एक्चुअली h जो है मेरा वो इक्वल टू 0 नहीं है, h की एग्जैक्ट वैल्यू 0 नहीं है, पर h एक ऐसा पॉइंट है जो बहुत अगर ये मेरा पॉइंट 0 है रियल नंबर लाइन पे, तो h इज टेंडिंग टूवर्ड्स 0, infinitesimally small value that tends towards 0 from both the sides। 1 minus h plus 2 means your x has become 1 minus h। all right, so what it is? It is 3 because h is something very near to 0, so we actually take it as 0। it's not 0, it is not equal to 0, but we'll consider it as 0 because it is very tiny tending to 0, so it is 3। all right, and now your right hand limit x tends to 1 plus f of x। all right, so here what is happening, we are tending towards 1 from the right hand side, we are tending, so for this part your value is x minus 2 for all x greater than 1, for all the x's greater than 1 the function's value is x minus 2, right? So we are tending from the right hand side, so we will take this value now, so it becomes limit x tends to 1 plus the function's value is x minus 2। all right, and when you change it in the h form, limit h tends to 0, it will become 1 plus h, because you are tending from the right hand side, you are inferencing it from the right hand side, so it becomes 1 plus h minus 2। so what is the value here? minus 1, right? because h will be taken as 0, so the value is minus 1। now you got left hand limit is not equal to right hand limit, right? and let us check for the value of the function at x is equal to 1 also। so f of c means f of 1, f of 1 is what? for x is equal to 1 we will take this value, right? 1 plus 2 which is 3। okay, so we got left hand limit is equal to the value of the function at 1 but not equal to the right hand limit, so overall this function is not continuous at 1, left hand limit is not equal to the right hand limit, all right, at c is equal to 1, therefore function is not continuous at c is equal to 1। all right, so at 1 at the point 1 your function is not continuous, but at all other points your function is continuous. If c is less than 1, your function is continuous. If c is greater than 1, your function is continuous. We did this using this definition of the continuity, but when we came to the point 1, we found that your function is not continuous at point 1. And how it is proved, you can see. We found the left hand limit. Alright, then we found the right hand limit, and then the value of that function is at 1, and we found that all the three are not equal to each other. So the function is discontinuous at 1, the function is not continuous at 1. Okay, so now we will talk about the algebra of continuity, means the basic plus of 2, addition of 2 continuous function, multiplication of 2 continuous function, subtraction and division of 2 continuous function. We will find whether they are also continuous or not. So your theorem says, theorem as stated says that if f of x and g of x are 2 continuous functions, at any point c. If at c your function is continuous, f of x is also continuous and gx is also continuous, then f plus g of x is also continuous and f minus g is also continuous. Alright, f into g is also continuous and f divided by g is also continuous. Alright, so what you are getting here is, if you take any 2 continuous function fx and gx, and if they are defined, it is already defined that f and g are continuous at any point c of the real number line. Okay, then f plus g will be a continuous function, f minus g will also be a continuous function, f into g is also continuous, and f divided by g is also continuous. We will prove it how. Now let us try to prove that f plus g is continuous at x is equal to c. Now for continuity, first of all you need to check whether the function is defined or not. You see, fx is defined at c, that's why it's continuous at c. Gx is defined at c, that is why it is continuous at c. That means f plus g is also defined at c. This is commonly understood. What we need to do is apply our basic definition of continuity. That means if your x tends to c, f plus g must be equal to the function f plus g defined at c, right? This is what we need to do. So limit x tends to c, f plus g is what? Limit x tends to c, f of x plus g of x, right? Now by the very definition of limits, you know you can split this. You know that limit x tends to c, f of x plus limit x tends to c, g of x, right? Now you know, since your f of x is continuous at c, that means limit x tends to c, f of x is equal to f of c, right? And similarly, it is given in this statement that the theorem states that g of x is continuous at c. That means limit x tends to c, g of x is equal to g of c, right? Your theorem itself says f plus g of x is continuous at c. You know, we started from this point. This was the given statement, f plus g of x is continuous at c, right? That means we will use this definition and write f plus g of c. This can be written as this, and you know this is continuous. This is also continuous because it is given. So what you got? You started from limit x tends to c, f plus g, and you got at this point. So you got the very basic fundamental, the very fundamental of limit, that says right. So that means your function is continuous. The first part of the theorem is proved. Similarly, you prove the other parts also. What your theorem states? It states that there are 2 continuous functions defined on the c, which is a real number, Okay, both of them are defined at C, and fx and gx are continuous at x is equal to C. Then f plus g is continuous at C, f minus g is continuous at C, and all those four. One I tried to prove, you will use the similar pattern to prove the other three also. So this is all about continuity. Now we will move further to different questions that are being found from this topic. Alright, till then try, read a lot and try to develop your concepts. Till then, thank you.